I work on plant biology and plant morphology mainly, anatomy, wood anatomy, tree rings. We are in a field trip of our program, this PIRE Create program, with NSF and FAPESP, this joint program, research program, in Brazil, in the state of Minas Gerais, in the northern part of the state. We are in the National Park of Peruaçu. Peruaçu is a very tiny river, but this very tiny river was able to create this magnificent cave and many other structures. The position of the Peruaçu Park in Brazil and in South America is very important for the understanding of the climate change, because we are very close to the limit between at least two ecosystems, two biomes. So we are in the northern limit of the Cerrado, the Brazilian savanna. Here in the south of the Caatinga. The Caatinga is the dry forest, the deciduous forest. And here we have deciduous forests like you have in temperate areas, because we are seeing forests on limestone. So these limestones, they drain all the water during the dry season, and so the trees, they behave as they were in a very seasonal place, like temperate places. And from the climatic point of view, we have many systems, climatic systems, that operate at their limits here. So any shift of these systems, these climatic systems, could change the climate here. So here is a special place because we have all this beautiful forest, many cave formations, a lot of proxies, a lot of records, and in a place that could show changes. So it's very important to work right here. And we are trying to do something very original, that is connecting the signals that are recorded in tree rings with the signals recorded in speleothems. Some of the stalagmites here, they have rings and they have layers that are annual, and tree rings are annual. And we can synchronize them, and you can read what trees tell about the climate in the last centuries and what the stalagmites tell about the climate in the same time. But trees here, we just found trees no older than 300 years old. But we have stalagmites with 1,000 years old, 10,000 years old, or 100,000 years old. So we can connect these two languages, the languages of trees and the languages of the minerals, and we can tell a story much longer and much deeper. So this is something very new. Also, we were trying to resolve and understand better inside tree rings how the rain history is recorded. So we are doing that in a very precise way that was never done in the tropics, to understand better how to read the signals in tree rings. So we collected water from the rainfall in the last 10 years, every month, and we are comparing some places in all this landscape to understand how the rain is recorded. So why is it important to understand that? Because we want to know if this rain was coming from the Atlantic Ocean or is coming from Amazon, and how much water we had, how much rain, if the rain season was smaller than now, shorter than now, or less strong. And so all these signals, they are recorded in trees and they are recorded in stone, but we need to learn how to read them better. We have several speleothems in caves, but not all of them are useful for climate studies or history studies. But the stalagmites, the ones that grow when water drops fall on the ground and they evaporate a little bit, they can tell a lot. They can tell us about the rain itself, the rain that fall on the top of the rocks and was infiltrated in the rocks. It can tell about the provenance of this rain. So if this rain came from far or less far from the ocean, for example. But there are another kind of signals that are really tricky. For example, when you have a huge volcano eruption in the Pacific or in the Indian Ocean, you have aerosols. And the aerosols are spread in all atmosphere. And they are here. And they can form a thick layer of these aerosols on the speleothems, on the stalagmites. And we can date it. So we can read the rings. So the rings tell the amount of water, but also we have minerals inside, micro-contents that tells about other stories. So in the speleothems here, in the middle of South America, we have the register, for example, of eruptions that occurred in Oceania, close Java, so the Pinatubo, the Krakatoa, the Laki. That history, it's here. Also, we can find the explosions of nuclear bombs. They are recorded here, in our trees and also in speleothems. So you use these dates that are very well known to help us to date exactly the layer of the stone you have or the correct tree ring, because they are super precise. When the rain evaporates in the ocean, you have a proportion of the normal water that has the oxygen with the weight 16, but you have some water with the oxygen 18. So you compare these proportions where water is being evaporated. And when the clouds are moving, the probability of a heavier water precipitates earlier is higher, is more likely to fall down earlier because they are heavier. So when the clouds are traveling, you lose some of this heavier water. And so you can in a certain way know that the water from the Atlantic traveled that much. So this water, when evaporates from the Atlantic, it has a signature, a characteristic proportion of these isotopes. But when it comes from the Andes, or it comes from Amazon area, it's different. So it's some things that we can try to understand. Our studies that are very helpful to understand the levels that the rivers around and the underground water were in the last millennium. And this is very crucial because in all this area, what we have is a very important river, the San Francisco River, that brings water to many states and many capitals. It means some millions of people. They bring water, they pump water for irrigation, and the economy is based on fruit exportation, for example. The society is getting aware how understanding climatic changes, not global change necessarily, but how our weather, not climate necessarily, but our weather changing slightly, how it can change our lives, with strong storms, thunderstorms, or tornadoes, or so on. We are seeing it happening. So it's what we are doing here, is studying how the changes occur, how fast, how deep. And we need to understand this story to be prepared.